Okay, Assalamualaikum and good morning everybody. So today we will continue with the example of cyber physical system which was proposed by Tran et al. In their paper Development of Cyber Physical Manufacturing System in the Industry 4.0 Context, which was published in August 2019. So I have uploaded the paper to uLearn for your reference later. So what I'm going to do today is simply explain the paper a bit and how this model actually can work in a manufacturing system. Okay, so they have proposed a model called Smart Cyber Physical Manufacturing System, or CPMS, as shown here. So individualized products, as we have discussed earlier, demands manufacturing system with advanced ICT embedded to it to enable the system to adapt to manufacturing changes. So on the management level, a digital studio provide means of customer interface to individualization of the product. For example, the customer may order their product using head-mounted display with automated guides for choosing the product characteristics in Digital Studio. Then the product information is sent to the design process and process planning department to generate scheduling for manufacturing the product. So here, the advancement of ICT in form of genetic algorithm helps to generate optimal process planning. In Smart CPMS, Internet of Services, or IOS, is used efficiently for sharing tasks from design to generation of the process planning. So on the shop floor level, the cooperation of IoT, or Internet of Things, among smart cells to carry out tasks is the key to Smart CPMS, and each smart cell here we can see includes a CPS, or Cyber Physical System. So if we take a look at this flow, okay, of the processes inside a manufacturing system, this looks eerily similar to a computer integrated manufacturing that we have seen earlier. So we've seen business functions, designs, planning and control, which are also computerized with multiple softwares and intelligent machines. So what sets these two systems apart? So it is actually the inter and intra-cell communication. Okay, that means internal communication inside the cell and external communication between the cell. Okay. And also ubiquitous computing, which is computation can be done with any devices, anytime, at anywhere inside the production system. And also the presence of cognitive agents. So in CIM, each element is not autonomous. Decision making must be done by human to gauge what needs to be done with the current system state. And often, intercommunication from the shop floor level to management level is hurdled by bureaucracy. Thus, it hinders the real-time decision-making that is much needed to accelerate the production time. So, in Smart CPMS model, at the shop floor level, CPS located inside each smart cell can communicate with other CPS inside and outside the cell. Okay. So it is crucial that the ICT infrastructure such as enterprise resource planning, manufacturing execution system, wireless network and sensor network is already in place and well established to enable reporting cell status in real time as well as inter-cell communication. Okay, so inside each cell, okay, cognitive agent technology is utilized to enable autonomy, intelligent behavior such as learning and reasoning to make decisions are carried out using artificial intelligence. Cognitive behavior is realized through perception from sensor networks and the knowledge obtained from the intelligence to come up with appropriate action. And then ubiquitous technology is then applied to machines so that it can be controlled and monitored in real time. This diagram gives an overview of a CPS model and how the cognitive agent behaves. So cognitive agent attempts to simulate or emulate higher cognitive abilities to address complex tasks in manufacturing. Cognitive agents are trained to read, learn, and decide on actions, typically using machine learning algorithms. We can think of cognitive agents as human supervisor replacements. It learns from a lot of information around it and past events to make decisions. So the cognitive agents work on the cyber part of the CPS model through these core modules, which includes communication, control, decision-making, perception, and knowledge. The perception module is in charge of getting and diagnosing status of the senses. Then together with the knowledge module, makes decision. So the knowledge module uses artificial intelligence to make reasoning based on currently delivered status and decision making made in the past. The control module then sends the new plan of action, such as the new cutting parameters, to the for machine tools, which then sends to the controller on the physical side of the system, and or requirement for cooperating with other CPS through communication module. Okay. So as we can see in this diagram, each of the smart cells may have multiple agents that works together to achieve a common goal. The simpler way to see this is as if you are an owner of an insurance company, for example. So you recruited agents to sign in as many customers from the population by training them and show them what to do based on your current knowledge and the knowledge of your past actions and its consequences. The agents then decide on their team to work together based on the intel and training that they receive. All of them have the capability of perceiving, making decisions based on knowledge and information around them, control the action that they do, and communicate whenever necessary. So the essence of having cognitive agents in CPS is like replacing human being as the decision maker, an action taker, as well as communicator.